How y'all doing? Can you guys hear me? Okay, good. All right. Well, welcome. And we're going to be talking about AWS here. My name is Eric Johnson. And let me kind of tell you a little bit about me, and we'll get started here. Like I said, my name is Eric Johnson. I am a AWS Senior Developer Advocate. I actually do work for AWS in this serverless group. So how many of y'all have worked with serverless at all? How many of you have even heard of serverless? How many are like, I have no idea what serverless is? Okay, good. There's a couple. We won't be talking about that too much, but ask me later. I'll be glad to tell you. But today, obviously, we're going to be talking about DevOps, and we'll talk about some serverless stuff in there. I am an AWS Certified Solutions Architect. I also am a father of 5. I'm a musician. Well, I'm really a drummer, so if you call that a musician or not, but I call it a musician, so I am a musician. I love Dr. Pepper, and I love pizza. So a little bit about me. Before we get started, I wanted to kind of give you, well, first of all, I want to say thank you for having me. I've never been to Moscow before. This has been amazing. Give you an idea of where I live. I'm from northern Colorado in a town called Johnstown. This is what it looks like at my house. So it looks a lot different here. It's really cool to see the city and everything. So I really appreciate it. I've had a great time. And thank you. All right, now before we jump in, I want to give a couple of rules when I'm talking. Some of you have already heard my rules, but I don't know if the rules are the right example or right word, but they kind of give you an idea. The first rule is this. This is any number I want it to be. Okay, so a lot of you are looking at me very seriously. That's actually a joke. It's okay to laugh. I know I have one finger. I didn't wake up this morning and go, oh my gosh, what happened? So, and I don't know how well that's going to translate. Does that translate okay? Okay, he gave me a great. So yes, I know I have one finger. I do make one finger jokes. It might make you uncomfortable. I'm okay with that. So it'll work out. We'll have some fun. The second rule is these are quotes, not apostrophes. I know that. I just can't. It looks a lot sillier than this. So I kid you not, I'll do this a lot when I'm talking. Like the other day I was, working or something like that, and I'll do this and somebody in the back will be, is he waving at us? I'm not waving at you unless of course I am. So, and these are thumbs. So, and I do thumbs up a lot. So those are rules that'll help you understand when I'm talking, you kind of figure out what I'm going. Again, comfortable about talking and making jokes, and I hope you are too. So let's jump in. So the first thing we're going to do is we're going to kind of define DevOps. Now, this probably isn't the exact definition that you may use, but the fun thing about DevOps is if you put 20 people in a room and you say, tell me what DevOps is, define DevOps, you'll get 20 different definitions, won't you? Yeah. So DevOps is kind of an ambiguous term. So for the purposes of this this meeting, DevOps, how we're defining it, is refer to a set of practices that emphasize the collaboration and communication of both software developers and information technology professionals, while automating the process of software delivery and infrastructure changes. It aims at establishing a culture and environment where building, testing, and releasing software can happen rapidly, frequently, and reliably. And it's kind of interesting when you talk about DevOps, we think about again, there might be a lot of different definitions, but when we talk about DevOps, we think about pushing code, right? It kind of is like, okay, it's getting code to our computers. But in the new world of serverless or containers or different things like that, we're also managing infrastructure. There's this idea of infrastructure as code that we talk about, especially at AWS, because our entire infrastructure can be defined in a YAML file or a JSON file. So infrastructure as code is important when we're talking about our DevOps process and understanding how that works. So this is our definition. Now when we talk about DevSecOps or SecDevOps, there's been a lot of different terms, but the idea of putting security in our DevOps, it looks like this. So where development and operations overlap, we have this idea of DevOps, and DevSecOps is where we want to secure that process. And that's what we're going to talk about today, specifically on AWS and some of the AWS tooling that's built to help you do that. So we can kind of jump in here. So first of all, let's look at some examples, and a little background from me. Before I worked at AWS, I worked for a partner of AWS, and I was a solutions architect. And my job is I sit down, and we would sit down with companies large and small, and we would look at their process. We would help them secure their workloads. We would talk about what's the best way to, make sure you're not going to get hacked, to make sure that if you are hacked, we can remediate that and all those kinds of things. But when we would move to their DevOps process, when we would say, okay, how do you deploy that? How do you push that out? We saw all kinds of different ideas and examples. And some of the basic, things that we look at when we're deploying is we see infrastructure where they're running things to, like, let's say, maybe VPC in AWS and a corporate data center. Okay. We also see examples where we're pushing out to ECS. Anybody using containers here? All right. Anybody use containers on AWS? Okay, a few of you. All righty. ECS. All right. How about EKS? All right, we got one EKS winner. Okay, that's good. So yeah, lots of containers, and that's still part of our process. And finally, this kind of is an idea of what a serverless architecture looks like. And if you think about serverless, and again, this isn't a serverless conversation, so to speak, but it's important to note because a lot of things are headed that way. Even if you're building infrastructure for servers, some of it's serverless, some of it's the infrastructure. We look at how do we maintain that, and how do we maintain the pipeline that's going to that. Today specifically, we're going to be talking about, try that again, there we go, talking about this area, okay? We could get into a lot of how do I secure this, but that's kind of out of scope for today. What we're going to talk about is how do we secure this on AWS, okay? And I may refer to some stuff outside of AWS as well, but this is what we're going to talk about. So first of all, let's talk about the security reality. The security reality is you're going to get hacked at some point. If you've had a computer online, it's going to get hacked at some point. It's not if, but when. That's the reality, and it's important to get that in your head. There was a study done here. It's been about a year since I read this article, but there was a guy who took one of these IoT cameras and he put it on his network, and he specifically put it on in his open zone. His DMZ is what he called it, but where it was open, just relying on the security in the IoT device. Now, someone take a wild guess how long it took for that device to get hacked. Someone want to throw out a number? 2 what? 2 seconds? Little fast, but not far off. It was 90 seconds. Within 90 seconds, that device had been hit with a Trojan device, and all its job was to say, hey, is this device exploitable? And if it is, let's call home to mama and get the big dogs to come out, and we're going to hack it. Okay? 90 seconds. How many? 90. Okay, you guys are good. Some of you are like, that's a 1. Well, that's a 90 because I said 90, okay? Those are the rules. Werner Vogels is he's the CTO of VP and CTO of AWS, my boss, way above me. He doesn't even know who I am, but he is my boss. And he said this, he said, everything fails all of the time. And you know, if I say that to like my kids or my wife, they're like, okay, yeah, whatever. But in our world, that's a very deep, effective statement. Everything fails all of the time. And our job is to say, how do we keep that from failing? But it doesn't stop there. In every conference, and it was kind of fun in my work, I did a workshop on Tuesday, and I had some folks in there that were what I call my what-if guys. And every time I teach a class or something like that, there's always that what-if guy that says, yeah, but what if they do get in? What do you do there? Well, you do this, this, and this. What if they get by that? Well, then you do this, this, and this. And our job as DevOps, specifically folks that are doing security for DevOps, is to be the what-if guy, right? So what that looks like is we're willing to say, I'm willing to bet that my system is going to get hacked. I'm willing to bet that someone's going to try to get by my security layers, okay, my security itself. And so what I need to do is think ahead. What if they get in? So that's your job. As you're looking at securing your DevOps, as you're looking at taking your DevOps from DevOps to DevSecOps, it is important to say, what if? And sometimes you sit down for an hour and just think, what if? Spend a day. And that's a great way to tell your boss, look, I'm working. It doesn't look like I'm working, but I'm doing my what if hour. You know, I don't know if that'll fly or not. Don't use my name if it doesn't fly. If it does, you're welcome to use my name. So the what if. So let's look at that. So here's the reality. In talking about that, when we build our security, we need to think about running layers, okay? Security is like an onion. It has layers. If you're a Shrek fan, it's like cake. Cakes have layers too, right? And so if you don't know who Shrek is, I'm sorry, there it is. But the idea here is when we build out our security for our DevOps in AWS, we want to use the layers of security. We don't want to just trust 1 or 2 or 5 or 7 or 93. We want to use all the layers that are at our disposal, because the reality is someone's going to get through some layers, but the more layers you have, the more chances you have of stopping. All right, so layers are critical to security. So what I want to do for a little bit here is talk about what are the layers of security that AWS offers. So let's talk through that. The account is the first layer of AWS security. How many of you even thought about the account as a security layer? All right, a couple of you are cheating because you were in my class on Tuesday, but that's, yeah, they're like, we knew, for 2 days now, we've known. Good job. So when you think about the account, here's a good example. I had a good buddy of mine call me up and say, hey, Eric, we had a developer working for us, and well, actually, he started with, we're not able to get to our EC2 instances. Oh, okay, well, what's going on? Well, we're trying to log in, and we can't get to the instances, and it's, I don't know, it's like our passwords are getting kicked out or something. It's like, okay, well, is it like that or is it not? He said, yeah, we're not able to get to them. I said, okay, well, tell me what happened. I said, well, you know, we need to get in there. And he said, here's the deal. We had this developer that worked for us, and he just wasn't working out. And so we fired him. We fired him yesterday. I said, okay, that's fair. You know, you don't work out, you get fired. That's fine. But today we're not able to get to our accounts. Okay. I said, so have you tried your root account? Have you tried to log in with your root account? What are you talking about? So what is your account name, or what is your account login? He tells me, and he's not using an account, what we call a root account, which I'll dive into a little bit more in a moment. He's using an IAM account. And the bottom line is his developer, I said, whose email address is on that account? So it's the developer. And I said, the one you just fired? Yeah, the one we just fired. I said, yeah, you need to make nice with that developer, because he holds the keys to the kingdom. The accounts are the keys to the kingdom, and it's critical that you understand that as the first layer, that whoever has the root account owns the system, okay? So let's talk through that for a second. A lot of times this is what we see when I'm working with the company. They'll come in and say, yeah, we've set a VPC up for our production, we've set one up for our staging, we've got one for our beta, we got our DevOps tools, we're good to go. So all right, well, how do you keep, does everybody have access to everything? And then sometimes like, yeah, we just have an admin group, everybody logs in under the root user, which makes me want to cry. It's like, no, don't do that. Or they're trying to do IAM policies to restrict them. But the reality of that is the simplest way to break down your environments really looks like this. Because the beauty of AWS is whether I run my EC2 instance here, or previously in a combined, it doesn't matter. It's all about you pay for what you use. Not for where you use it, for what you use. So the first level of security is saying we're going to create an account that for beta that only beta people can get to. We don't care if you break this, that's fine. That's what it's for. Let's test on breakaway. Then we're going to create another one. We're going to add some limitations to it. Okay? There's a few folks who are like, you're never going to get an access to this account because there's no way. They wouldn't give it to me. And so what we do is we lock that down. Then in production, we say, okay, only 2 people or a specific group, use groupings when you can get to this account. And so as your first layer of security, by using accounts, it's a real easy thing to do. But I know a lot of people will ask, well, yeah, but that's kind of a management nightmare. If I have, let's say I have, because yeah, that's great when you're just talking about 3, but what if I need 300? What if I need 45? How do I manage that? Well, AWS kind of has an answer for that. We have a thing called the master account. Okay? And so what you're able to do is you're able to create a single account that it handles all your billing and your management and things like that. And then you're able to spin up other accounts and link them. And so this account will pay for them. But I might be able to handle all the billing and stuff, but I can't get to this one unless I have the right credentials. I can get into this one, but maybe not this one. So you're still able to lock people out using roles and policies, but you can still manage your billing and create different things. So the account, again, is the first layer of security. So let's talk about the second layer. The user is the second layer of security that you want to employ. I already talked a little bit about a root user. I want to talk, does everybody know what an IAM user is? Raise your hand if you know what an IAM user is, okay? IAM is Identity and Access Management in AWS, okay? When you open an account, you open what's called a root account, okay? And a root account supports MFA, which is multi-factor authentication, dashboard access, programmatic access, full account access, and it cannot be locked out. Okay? They're the owner of that account. But that root user can then create sub-users called IAM users. And they support MFA, again, still have multi-factor authentication. They have dashboard access, programmatic access, fine-grained access, so you can start limiting what they can get to, and can be locked out. So your critical differences between those is root user has the keys to the kingdom and cannot be locked out and has access to everything, whereas your IAM user can only have fine-grained access and can be locked out. So this guy misbehaves, that guy can lock him out, or an admin user can lock him out. So really good practice, and there's some best practices when you're looking at the 2 types of users. So for the root user, when we talk about the best practice for them, what we do, and here's what we suggest, okay? Use a recoverable email address. Don't assign it to the developer you're going to fire. That's just key. If you're going to fire a developer, don't give them the keys of the kingdom, right? So use something like a group email or something like that that multiple people can get to, or that the right people can transfer. Remove programmable access. When you create an AWS account, you get 2 types of accesses, okay? Number 1 is programmable. What that means is that through my CLI or through API, I can access my account and do stuff. I can do damage, okay? So then there's also dashboard access, which means I can log in and point and click and do the stuff from the console, right? So those are 2 types of accesses. So what we suggest is remove programmable access. Don't code against your AWS account with the root account. If you fat finger, you can break something. Does everybody know what a fat finger is? Fat finger means I hit the wrong button, okay? And that's critical bad, right? So enable MFA, store in a very secure place, and then do not use and lock it up, okay? Don't use that ever unless it's emergency, okay? However, when we're talking IAM users, it's a little different. With an IAM user, number 1, we always enable MFA. Okay, for highest security, use the multi-factor authentication. There's multiple ways of doing that. You can use, the phone with the queue. You can use the RSA tokens. You can use a YubiKey. There's different ways of doing that. Grant least privileges. And what that means is, I'm going to start you with the absolute bare minimum amount of privileges that you need to be able to do your job. And it may take me a couple times to get it right, but the other options, a lot of times we go, I'm just going to throw you in the admin group. You have access to everything. Then you're not, it's like, why even use it at that point? So you really want to start, our best practices IAM users. And I know you may be saying, you know what, Eric, you're being over paranoid. But the reality of that is, you may get an employee that, he's trustworthy, he looks trustworthy or something like that, and probably they are. But there's always that chance of something going rogue. And if someone goes rogue and hacks and breaks and steals and whatever, and then takes off, you're going to probably hear about it. So your job as security administrators and DevOps administrators who are in charge of security is to lock those down, okay? And don't apologize for it. This is how it is, okay? So, disable unused users. Don't leave users lying around. Employ user groups. Just like if you've done Windows administration, there's user groups in AWS. So you can create a user group. So this user group has access to code deploy and code pipeline and code build. This user group has access to Lambda and whatever. So you can build those out. So to try not to use it at the individual user, do it in groups. That way you can lump groups together. Employ managed policies. Managed policies are policies that AWS creates. Now you can create your own, but start with AWS ones because they're tightly locked down to the best and most efficient way. If you can't find an AWS managed policy, then you can use your own. But start with one of the AWS managed policies. Use groups to assign permissions. Talk about that a little bit. And then configure strong password policy. I don't think I need to explain that. You guys know what that means. And rotate credentials often. You can force that credential rotation. So these are some security steps that you want to take on your IAM users that help lock those down. Next level of security is handled through roles and policies. Now roles and policies, so these are all part of the IAM construct in AWS. They're all, and everything you do is going to require some type of access through a role or a policy. And I'm not going to lie, there's a learning curve to it, and it can be kind of tough sometimes. But one of the things, if you're going to work in AWS and you're going to work effectively, you want to take the time to understand how the IAM system works, how identity and access management works. So roles are an IAM entity that define a set of permissions, okay? They don't define permissions themselves, they define a set of permissions, okay? They can contain one or more policies and is assumable by trusted entities such as IAM users or AWS services. Now let me take a moment and explain that because it becomes very powerful if you think about the way this works. So if I create a role, and this role, let's say, allows me to deploy using code deploy and using code pipeline and the different tools that I use, then I can allow CloudFormation to assume that role, which means, hey, you can act as this role for a certain period of time. So they get all the permissions that are needed. That way I don't have to double up on those permissions and apply them somewhere else. The same thing with users. I can say, hey, when Eric Johnson logs in, he automatically gets this role. And that role can do this, this, and this. Okay? So there's this, they're able to do that. Another good place to kind of see this, and it's a little bit outside the DevOps, but is, did you know that on an EC2 instance, I can apply a role to an EC2 instance, and that role will allow that EC2 instance to read from an RDS database without the password? Okay, so what happens is you're no longer having to get the password to that EC2 instance, you're allowing roles to do their job. You can also revoke that if needed. And the EC2 goes away and nothing happens. Or another EC2 instance is added into that role and it has the access as well. So roles are very powerful. Policies are a subset of roles, okay, or a subset that can be used. And policies define permissions for an action. And there's multiple types of policies. There's identity policies, there's resource policies, and there's access control lists. Access control lists, how many of y'all have ever read in the news there's been a breach of an S3 bucket? Okay, someone in the back there. In America, you see this a lot. Well, you see it all over the world. And what it is Amazon gives you a set of policies to lock down your buckets. And misunderstanding an access control list or a resource policy can ruin your day. There's been a lot of companies, banks that have had access to, they've lost access, or I'm sorry, they've had open access. So understanding those, very important. So when you're looking at a role in a policy, when you're setting this up, here's some quick kind of best practices. Break up policies by resource. Use AWS defined policies, we talked about that, grant least privileges, and use policy conditions for extra security. And what that means is, I'm going to say, here's my logging policy, and it's everything to do with logs. And here's my DynamoDB policy, and it's going to deal with DynamoDB. And then I can add conditions, and I can say only, and this is really cool in DynamoDB, I can say you can only get to these set of rows, if you're a certain user. So you can do row level granular security on a DynamoDB table with roles and conditions. So very powerful, fairly complex. So the second, I'm sorry, not the second, but another thing we're going to talk about today is secrets. How many of y'all know when I say secrets, what do you mean? Okay. Right, it's like, is he telling a secret? Yeah, I'm telling a secret. Secrets are passwords, are anything that really should be encrypted and stored away. And we see a lot of different ways of handling secrets. I know I've had this before where I've checked in my code on GitHub. You can get a token from them that you can give to somebody else where they can get access to your repo. And I accidentally had that in my code and I checked it in one time. And now my code was checked in for all the other developers to see. And what was kind of cool is GitHub sent me an email, said, hey, we noticed one of our tokens just wide open in your code. We've disabled that token. It's like, oh, thank you, because I blew it. Yeah. Now can you delete it and tell everybody I didn't really do that or blame somebody else? That would be the best. So, so secrets. So how do we deal with secrets? So here's some common patterns for secrets. First one we see is hard-coded values. And so when you do hard-coded values, it gets stored in the code repo. So already, that's bad, right? We don't want to store code in a repo. It also gets stored on a server if it gets pushed out. It's also on developers' machines. So it's in a repo, it's getting pulled down, right? It gets shared with the developers, and it's a maximum blast radius, meaning if this blows up, it can be huge. It's everywhere, right? And finally, it's available at rest and transit, meaning people can pick it up from a machine or when it's being transferred. So storing secrets in hard-coded, not good at all. So and you can see it, my exposed username, my exposed unencrypted password. Even if we encrypt that password, I have seen where, no, we took the time, we encrypted it, but right in the code was the salt to decrypt it. Okay, well, all right, so you've made it 3 lines harder for me to decode your password. Thank you, all right. So, not a good place to keep them. Next pattern we see for secrets is environmental variables. The question on those, let's get tough because we decide where do we store environmental variables? How do we get them out there? Especially when we're talking about infrastructure as code, right? So when our infrastructure as code is stored in a YAML file or a JSON file, where do we store those environments? A lot of times we can pass them in. You do have the ability to pass them in, but they become a management nightmare. Trying to figure out, all right, who's got them to pass them in, who's going to use them. It does make a smaller blast radius, but there's still a blast radius. It becomes problematic in managed services, where you're passing them in as parameter. They're exposed on the dashboard. On a Lambda, if I pass in a password as a parameter, anybody with access to that dashboard, so somebody else that has access to it can go in and look, and there they are right there in the variable. Now I can then encrypt them, but again, sometimes it's too late. It's steps that we shouldn't have to take. So another pattern we often see is external central config files. Not necessarily a bad thing. People will do, hey, look, they're in a secured S3 bucket. We're going to lock it down in a secured S3 bucket, and then we'll grab. But at this point, you've got to deal with the grabbing and encoding and all that kind of stuff. So it's, again, smaller blast radius. You're having to hand roll and fetch implementation, and it can add latency, right? So so let's say I need a real fast response, but I've got to go grab some passwords from an S3 bucket. Not much latency, and probably not recognized by too many people, but it adds latency. So generally, again, it is an option, but sometimes not the best. So let's talk about what are best practices for secrets. The first one is there's two options that we look at, and they're very similar. The first one is the AWS Secrets Manager. And what this does is this allows you to store your parameters it's at an account level secrets manager. So if I have a dev account, a staging account, and a production account, I could put data into this secrets manager, same name, and then it just automatically, I just tell it, hey, grab from the secrets manager from whatever account you're in, and it's going to get the value. And what's really cool is it offers some different things, like it rotates secrets safely on supported services like RDS and other databases. So it's going to handle rotating that. Let's say you have a database password, you sync it up with RDS, and I'll show you in a second how that works. It provides code examples. It's secure and audits secrets centrally, manages access with fine-grained permissions. It does the encryption and decryption for you. So when I do the request, I literally just say unencrypt while it's grabbing it, or decrypt true. Now, you may think to yourself, well, that's not much of a security level. Well, your account, whatever you're working as, whatever assumed role you have, has to have the rights to decrypt that key. Okay? So the security's in there, but it's done through a role, and you have the permissions. So let's think what that looks like. So how that works is the user's going to put into the secrets manager, you can use the CLI, the API, or the dashboard. He's going to put a value into the secrets manager. Then what's going to happen is the secrets manager, this is on a rotating, if you're doing a rotating, the secrets manager is going to spin up a Lambda to manage this, okay? And then that Lambda is going to manage the password in the secrets manager and your RDS database. So it's going to rotate those for you on passwords that you won't even need to see. You can grab them if you need to. Then what happens is when your user comes in and it goes to hit your Amazon EC2 instance, he's going to grab from the secrets manager the password and be able to hit the database. Okay? And that's if I'm not doing a role. I could do a role where it hits it directly, but that doesn't work with every version. So if I do need a password, this works with all of them. So that's how the secrets manager works. If you don't need the rotating and you want just kind of a little bit of a simpler implementation, there's also something called the parameter store. And this is much like the secrets manager. In fact, it's probably what we call the first iteration of the secrets manager. And what this allows you to do is again, you insert data into the parameter store and the user adds code to get the secret. So it's literally just an SDK call. Okay, and you might be thinking, well, why is that better than grabbing from an S3 bucket? Well, number one is it's account specific, so it makes versioning very easy. I have a staging, I have a beta, things like that. Number two, the SDK decrypts immediately for you if your role has authority. So a lot of the things that you'd have to hand roll are handled automatically. And the code uses obtained credentials to query the database, much like earlier, but instead of the rotated, it's not rotated here. So this could also be, you know, a Stripe key if you're doing payments, something like that, another API key. So those kind of data, and you can store just string values. You can also store encrypted values there. So that's where we store secrets. Alrighty. Finally, when we talk about the final best practice for secrets, and I've already alluded to this, so I won't spend much time here, but use IAM roles when you can. Try not to use passwords if you don't have to. Use the roles and policies to lock it in. Okay? It provides fine-grained role-level access. Dynamite talks about that. It allows authenticated users to assume roles using Cognito. If you're dealing with authentication, you can do that there. So roles and policies in your DevOps process, very handy. Last thing we're going to talk about is automation. Man, automate all the things. All the things need to be automated. And there's several reasons for that. I love this quote by Bill Gates. It says, the first rule of any technology used in business is that the automation applied to an efficient operation will magnify the efficiency. You've done a good job. However, the second is that automation applied to an inefficient operation will magnify the inefficiency. So the first rule of automation is make sure it's worth automating. Get your system locked in. We'll talk about that for a second. So here's why you automate. Number one, you want reproducible process. Number two, you want predictable outcomes. Number three, you want to minimize the blast radius, removing human error, and reduce wasted man hours. Humans equal security risk, especially in the DevOps process. If you're, and I can't tell you how many times this happened, we'd sit down with the company and say, tell me about your DevOps process. Well, Bob compiles it on his desk, and Jim then takes and pushes it out. If your automation process includes somebody's name, it's not automated. Simple rule, right? So you want to understand that humans introduce error, and it's also a waste of their time. Most DevOps processes, 99.999 to the nth degree, can be automated. Take advantage of that. Here's what a non-automated system looks like. Developers push to Git, Bob the builder grabs it. You see the process. It's got people, it's not automated, it's slow, it's cumbersome, and it's not reproducible. It's going to look different every time. Here's what an automated process looks like. We're using the tools that go through here. Now, I know we haven't covered all these, but if you think about, this is where you commit your code. Code pipeline's going to take and test that. Grab that code, it's going to test and build it with code build, and then deploy to one of the different things here. So all of that can be secured in the measures that we've been talking about today, and it's fully automated without human error. It has to be efficient, it has to work, and then you automate it. Okay? And these are the tools that are there. Automated configuration, there's several tools that are given out there to do that. CloudFormation, Systems Manager, OpsWorks, and Service Catalog. Service Catalog is one of these that allow you to build out services, and then that's what your people can use. It's a way of saying these are the systems you need to use, okay? And that's how you can. That's one of the ways of automating configurations. OpsWorks is Chef in AWS. There's different tools for what you need to do. Finally, automating monitoring. Amazon CloudWatch. Anybody used CloudWatch before? All right, CloudWatch is your friend. Okay, CloudWatch is going to be where all your automation, this is the what went wrong. How about CloudTrails? Anybody know what CloudTrail is? All right, yeah. So where CloudWatch is going to tell you what happened, here's the best part. CloudTrail is going to tell you who did it. Okay, it's the blame game, right? And that's critical in our industry, so we're able to say, who made this change? Oh, hang on. Oh yeah, I know who did it. So that's critical. So Cloud tells you who did it. AWS config. This will monitor your system and tell you when something isn't as you expected it to be. You're able to set preset variables and say, hey, if someone's going to spin up a box, it needs to be this kind of box. And it gives you the ability to monitor that. Use the tools. I really encourage you. My rule of thumb, if I were to do rule of thumbs, is number one, managed services. What tools does AWS already provide? Number two, if you can't find the tools, look for third-party services. That might be a Jenkins or a Hudson or something like that. Number three, if neither of those are available, then look at rolling your own. But don't roll your own first. It doesn't make sense, right? The tools are out there. All right. I'm going to be in the Ask Me section a little bit, although some of you might be doing the Slido, and I'll be glad to take a couple of questions that way. But that's all I've got as far as security, and so I'll go ahead and switch over to the Slido here. Real quick, I'm going to give you this. This has my QR code. I think this is thank you in Russian. Is it? Okay. All right, now work with me. You ready? Добрый день. Yes, she's like, no, that wasn't even close. All morning she's been teaching me this word. So, but yeah, grab this QR code. This is my Twitter handle. With Twitter handle, you'll hear a lot about AWS, and you'll hear a lot about my kids. So it's the good and the bad. So you can, or a lot about what stupid thing did I do today. There's been a lot about Moscow and crazy things I've done here. So I won't even tell you. You can read them. So, all right. So I'm going to switch over to the Slido, and I can answer any questions that we might have real quick. All right. Hey, look at that. Hey, someone's following me. Thank you. All righty. AWS Secrets Manager provides over tools like HashiCorp Vault. So the main thing, and I'm not real familiar with HashiCorp Vault, but almost always the answer will be the integration with AWS. That'll be the first thing I would tell you. When you use the AWS Secrets Manager, you have wrapped around it all the security measures that AWS puts in place, like IAM control, roles, policies. The other thing, and again, I'm not familiar with HashiCorp terribly, but I'm familiar with HashiCorp, but not their vault, but is the rotation. The Secrets Manager provides the rotation that's built in and already available. All right. G Suite, Google, SSO, where to manage groups, or rather, what better be done on G Suite's side? I couldn't tell you, I don't work for them. So, I use G Suite for some of my own domain, but yeah, I don't think I can with any kind of authority answer that question for you. So, could you, that's it. Those are the only two I see. Any other questions? Have I done so well at explaining myself that there are no questions? That's how I take that. Or we're bored to tears and we would really like you to stop talking. So, but I like the first one better. So, alrighty. Well, guys, that's all I have. Thank you so much for your time, and thank you for staying awake. So, thank you.